Assalamualaikum and hi, it's me again, Miss Huda. Let's continue on example number 5 for shear force and bending moment diagram. Example number 5 shows that this is a cantilever beam. It requires you to draw the shear and bending moment diagram. There are UDL and 2-point loads, and at A there is a fixed support, which means that the free body diagram going to look like this. There would be one horizontal reaction, one vertical reaction, and another one is moment reaction. We can start to calculate the reaction at A for horizontal reaction. R at X will be 0 because there is no horizontal force. We can get the moment reaction by using the moment equation. So you have to take moment at A. You have one reaction here from the moment due to fixed support, plus you have one loading UDL going to A for 6 meter, that's why you have to times with 6, and from the center it's going to be 6 meter divided with 2. This 2 is force and this one adalah distance ke A. You have 8 kilonewton point load going to A. It is 8 kilonewton and the distance going to be 6 meter. You have another 8 kilonewton pergi ke A. It is 8 meter the distance. Semua ni positif sebab dia adalah clockwise ya. Dan moment dekat sini adalah based on our assumption. Then I will get the value of moment adalah 292 kilonewton meter, the reaction ya. And we can get the reaction for RAY. You have RAY, one loading UDL going down for 6 meter length. You have 8 kilonewton the point load and 8 kilonewton point load. And you will get RAY equal to 76 kilonewton. And value RAY positive maksudnya memang our reaction naik ke atas. Moment is negative 292 kilonewton meter. Therefore, the moment is actually counterclockwise. Terbalik daripada our assumption yang dia sebenarnya clockwise ya. Next, we're going to draw the SFD and BMD using the graphical method. First, you have to draw the line for each forces ataupun reactions points, then the line for SFD and BMD. First, you have 76 kilonewton force, the reaction RAY going up. So SFD, you have to mark dekat 76. Next, for 6 meter, there is a UDL. Therefore, 10 kilonewton per meter darab 6, dia jadi 60. So, 76. Dia UDL, dia turun ke bawah loading ya. So, 76 minus 60 kilonewton. Then you get 16. Draw the line. Next, you have point load 8 kilonewton here going down, meaning 16 minus 8. You will get 8 kilonewton. Next, 2 meter, there is no forces ataupun loading. Then it will go straight and you see there is 8 kilonewton point load going down minus 8. Then you will reach 0. Lepas tu dah tak ada lagi loading, dia akan pergi straight saja, meaning kosong lah for the next 2 meter. To calculate for BMD, you have to calculate the area of SFD. So for the first area, I'm going to mark it as 1, and the second area, I'm going to mark it as 2. For area number 1, this is a trapezium, therefore half times with 76 plus 8 times with 6 meter. Then you will get a value here. And for area number 2, this is a rectangle. It will be 8 kilonewton times with 2. Then you will get 16. 16 ya. Ini. So ini adalah 16. I get 276 kilonewton meter. We can draw the BMD, right? So you're going to start with 0. At the same point A ni, you nampak ada satu moment. So moment akan masuk dekat BMD ya. So it is counterclockwise, jadi dia negative. Therefore it is negative 292 below di bawah. Then you have the first area 276. This is positive value. You kena tambah lah. So negative 292 plus 276. You will get negative 16. After that, there is a second area 16 kilonewton meter. So negative 16 plus 16 sebab dia berada kat positif. Then you akan dapat kosong balik. For UDL, remember that dia mesti curve ya. Dan untuk area yang tak ada force kat sini, dia mungkin akan jadi slanted line. The maximum shear force will be the highest value, which is 76, and the maximum bending moment going to be 292 kilonewton meter. We're going to do the sectional cut method. For sectional cut method, the way you find the reaction masih sama. Sorry, dekat sini negative 292 kilonewton meter, meaning that you can go counterclockwise. We're going to cut this beam to sections. So first, I akan cut dia before 8 kilonewton point load, and then I'm going to cut another one before the 8 kilonewton, and I'm going to cut it for the next 2 meter yang paling hujung. I'm going to call the first cut as B, the second cut as C, and the third cut as D. For the first cut, the boundary going to be X must be bigger or equal to 0, but must be less than 6 meter. Start dari sini, pergi ke sana. So, 0 sampai 6. Finding the reaction untuk sectional cut kita, which is we have one shear force and moment. Tak ada assumption kat sini, fix ya, pakai arah macam ini. From left, there is a 76 kilonewton, the reaction of REY. Next, you have 10 kilonewton per meter, that is the UDL. That the length is X meter sebab kalau UDL, you mesti darab dengan length beam tu kena UDL, baru dia akan jadi force. Ini pun force. Okay, sebab meter pangkah-pangkah dia akan jadi kilonewton. Then you have last kali V turun ke bawah, so minus ya, negative. Then kita calculate, simplify, we get V is 76 kilonewton minus 10x kilonewton. we have the moment equation sebab kita nak dapatkan reaction untuk M ini. You have one moment which is 292 counterclockwise, therefore negative. You have the force 76 kilonewton going to the B, meaning the distance going to be X meter. You have one UDL 10 kilonewton, that is the length is X meter. Okay, ni adalah force. And the distance from the centroid is going to be X meter bahagi 2. That's why you have to times with X meter bagi 2. This is the distance. And minus dengan M, the reaction. Simplifykan and you will get this value. For the next section that we cut, kita akan cut di sini. Right? Okay, so I call it C and dia dari X-nya dari 6 sampai 8. That is the limit X adalah dari 6 sampai 8 meter. I start with force equation first to get the reaction dekat V. Masih lagi stick dengan this direction ya. V mesti turun ke bawah dan moment mesti counterclockwise. You have one force 76 kilonewton, the RAY reaction. You have 10 kilonewton, this is the UDL. Okay, beza sikit kat sini bukan darab X sebab sekarang ni limit kita dah sampai X, dah lebih lagi daripada hujung UDL. So kita dah ada panjang UDL ni, which is 6 meter. Therefore darab dengan length UDL. So dua ni adalah force ya. And you have 8 kilonewton. This is the point load. So semua loading mesti minus sebab dia turun ke bawah kan. So tolak lah. The last one, the reaction V turun ke bawah, so minus V. And simplify, we're going to get V equal to 8 kilonewton. Next, kita akan cari the reaction dekat M pula. By taking moment dekat C, we have one moment here, which is the reaction daripada fixed support tu. Counterclockwise, negative 292. We have the RAY going to C. You have to times with the distance, force darab distance. You have UDL, which is 10 kilonewton per meter, and the length of beam yang kena UDL tu adalah 6 meter. So about the distance here, sebab ini panjang dia X meter kan, jadi you have to, daripada distance ni, you kena tolak lah dengan panjang ini. Okay, sebab dia pusing macam ni kan. So separuh daripada the UDL. Okay, so kalau separuh dari UDL, 6 meter bahagi 2. So tinggallah 3 meter. So sebenarnya di sini 3 meter. So X tolak dengan this 3 meter. So dapatlah distance nak ke C. You have 8 kilonewton pula going to C. The distance going to be X meter minus dengan 6 panjang ini. Force darab distance. And last kali you ada reaction dekat section yang you cut, which is counterclockwise, tolak M. Then you can simplify, you get negative 64 kilonewton meter plus 8x kilonewton meter. That will be for section kedua yang you cut. For the third section, last kali saya cut di sini. Okay, so it's going to be from 8 meter to 10 meter. That will be the boundary for X. The reaction masih sama, stick to this direction. So you have one RAY 76 going up positive. You have 10 kilonewton per meter. This is the UTL, and you have to times with the length of the UTL, baru dia jadi force ya. And UTL dia adalah loading, dia mesti turun ke bawah, that's why dia minus. Next you have 8 kilonewton turun ke bawah juga, so minus. And last kali untuk loading, you ada 8 kilonewton going down, so minus juga. You have one reaction for the section that you cut going down become minus V. So V is equal to 0. Next, we're going to find the reaction dekat section yang kita cut for moment. Take the moment dekat the section yang kita cut tu. We have one moment here, negative 292 because of it is counterclockwise. And you have 76 kilonewton. The RAY pergi ke D darab dengan X meter. It is clockwise, jadi positive. You have the UTL 10 kilonewton untuk 6 meter. So ini adalah force. And the distance nak ke D tu adalah dari tengah sini pergi sini. Okay, so you have to minus dengan 6 meter bahagi 2 kat sini. That's why X tolak lah dengan 6 meter bahagi 2 tu. Dia adalah counterclockwise ya, negative. We have 8 kilonewton going to D. The distance going to be berapa distance ini? So X minus dengan 6. And last kali our 8 kilonewton for the loading ya, pergi ke D. Kita tak boleh include lah distance ini, so maksudnya X minus dengan 8. And the counterclockwise jadi negative. We have one moment here which is the reaction from the section yang kita cut. It is counterclockwise, therefore negative M. Then we can simplify. Okay, jadi kat sini dia jadi 3 meter ya. So you kena darab dengan semua ni ya. Ini darab ni, ini darab dengan ini. Lepas tu semua ni darab dengan ini. This one darab dengan ni, ini pun darab ni. Ni darab ni pun kena darab this one ya. So baru simplify everything and you get M equal to 0. Kita dah dapat all the reaction, the M and V for all 3 sections. Next kita akan copy all value of the V dan M ya. Untuk setiap boundary yang kita ada. Untuk boundary this one, ambil this one. Untuk boundary ini yang terakhir, ambillah the V dan M. Then we can start to draw the SFT and BMD. Okay, draw the line for each points yang ada loading and the line for SFD and BMD. For our first limit here, we have V equal to 76 kilonewton minus 10x kilonewton. Then you're going to replace this value dengan boundary masing-masing ya. Value mana? Value X ni lah. Mula-mula you replace dengan value kosong dulu. You akan dapat 76 kilonewton tolak kosong. So jadi 76 kilonewton. That's where you akan buat ya, sebab dia akan start dengan kosong dan naik ke 76 sebab you kira value dia positif ke atas lah. Kalau X sama dengan 6 meter for the second boundary value tu, you akan replace ya X ni dengan 6. So 76 tolak 10 darab 6. 76 tolak 60. You akan dapat 16. So you boleh gariskan straight. For the next boundary, 6 sampai 8 meter. Ya, dekat sini. V equal to 8 kilonewton. Okay, meaning that dia fix 8 kilonewton sepanjang 2 meter tu. Maksudnya, dia turunlah 8 dan akan pergi straight 8 sebab value dia tak berubah. For the next 2 meter, boundary dia adalah X sama dengan ataupun lebih besar 8 kurang ataupun sama dengan 10 meter. The V value adalah 0. Therefore, dia turun ke bawah pergi ke 0. Dan straight lah 0 juga, tak berubah ya. Jadi siaplah kita punya SFD. Next, kita akan buat untuk BMD. For BMD, on the first boundary we have, which is 0 sampai 6 meter, masukkanlah value X ni, gantikan dengan 0. So, negative 292 plus 0 minus 0. So, tetap jadi negative 292. Next, we have 6 meter. So, replace lah dengan 6 meter kat sini. Negative 292 plus 76 darab dengan 6 minus dengan 5, 6 darab dengan 6 kuasa 2. You akan dapat negative 16. Dan simply letaklah negative 16. For the second boundary, which is X must be more or equal to 6, but must be less or equal to 8. Maksudnya 6 meter sampai 8 meter. Jadi replacekan mula-mula X ni dengan 6 meter. Negative 64 tambah dengan 8 darab 6. So you akan dapat negative 16 juga, sama ya. Dan kalau dia 8 meter, masukkan pula 8 meter dekat sini. I get 0. Okay, so dia akan go back to 0. Dekat 8 meter So bila you kira pula for the next limit, which is 8 sampai 10, M adalah 0. Okay, so maksudnya di sini tetap 0, kat sini pun 0. Dan boleh buat straight line sahaja. Siaplah our SFD and BMD. Next, kita akan tengok the maximum shear force and maximum bending moment. Right, so our SFD and BMD sama je macam the graphical method. It's just that kelebihan dia, you can get the value kalau you nakkan value. For example, kalau X sama dengan 2 meter, you nak dapat berapa value V dia, you boleh cari dengan masukkan dekat mana? The first one ni lah, sebab inilah boundary dia. 0 sampai 6 meter. X sama dengan 2 meter tu masih dalam boundary ni. So, replace lah dalam the equation itu. Then you can get the value at that particular point. That will be all for example number 5. And this is our last example. Okay, thank you so much. Bye.